Okay guys, diving right into our bell ringer, we're going to start by multiplying by powers of 10 and 100. 367 and 8/10 times 10 means that we're going to take 367 and 8/10 and just move our decimal point over one spot to the right. So our product is going to be 3,678. 367 and 8/10 times 100 means that we're going to take our number, add a 0 as a placeholder, and make some adorable little baby butt cheeks. Move your decimal point over 2 spots to the right, 1, 2. And so our product is going to be 36,780. Okay, now remember, when we divide by powers of 10 and 100, our decimal point moves the other way. So we're going to take 367 and 8/10 and divide that amount into 10 equal pieces. Rewrite your number. Move your decimal point over one spot to the left. So our quotient is 36 and 78/100. When we divide 367 and 8/10 into 100 equal pieces, that would be like saying I have saved up $367.80 and I want to divide it with 100 of my closest friends. Is everybody going to get more than $100 or less than $100? Way less than $100 because I'm sharing it with 100 friends. So I'm going to move my decimal point over 2 spots to the left. Oh, look at those cute little baby butt cheeks. And so my quotient is 3 and 678 thousandths. So if I shared this amount of money with 100 of my closest friends, everybody would get just under $3.67, or you could round up to $3.68. 3 and 678 thousandths is my quotient for that one. Okay friends, here we are working on our measurement problem. Now in order to solve this first one, you need to know that there are 12 inches in 1 foot. So picture just your basic, standard, typical school ruler that's been divided into inches, and there's 12 inches on that 1 foot. That's a really bad picture, I'm sorry. But just to give you a sense of how big a foot is. People also say that the space in between your elbow and your wrist is about a foot, so that's kind of a good ballpark as well. All right, we're gonna take 134 inches divided by 12 inches in a foot and figure out how many feet that is. And I know I need to divide because fly to horse divide, of course. I always have to just double check that with myself. Now this is an interesting problem because we're going to have a remainder. And since it's measurement, I'm going to have you put your remainder into a fraction. So we're going to divide 134 by 12. How many times does 12 go into 13? 1 time. 1 times 12 is 12. Subtract. 13 minus 12 is 1. Bring down your 4. How many times does 12 go into 14? 1 time. 1 times 12 is 12. And 14 minus 12 is 2. So we have 11 feet with a remainder of 2 inches, which I'm going to put in fraction form. So that's 11 and 2/12. Bonus points if you know how to reduce that, but I'm not going to teach reducing to you right now just because this is a little bit, it'll just take too long. Okay, now for the second part of the problem, we're going to convert 64 ounces to some number of pounds. Now, in order to solve this one, you need to know that there are 16 ounces in 1 pound. So for this one, I would think of like a pound of butter that you would buy at the store that would have 16 ounces of butter in it. Or a pound of sugar would have 16 ounces of sugar in it. Let's see. Fly to horse, divide, of course. So we're going to do 64 ounces divided by 16 ounces in each pound. And let's figure that out. Now, to solve a problem like this, it's really not going to be efficient for you to try to do long division, because you're going to spend so much time figuring out how many times 16 goes into 64, you may as well just skip the long division. And here's what I'm going to suggest you do. Let's start with not 64 divided by 16, but 64 divided by 8 instead. Thinking like compatible numbers. 64 divided by 8 is 8, which means that 64 divided by 16 must be 4. So when I doubled my divisor, I had to cut my quotient in half. Okay, so 64 divided by 16 is 4 pounds. All right, it's equivalent fraction time. Equivalent fractions are fractions that have the same value, even though their numerator and denominators may be different. So same value fractions. When you're thinking about equivalent fractions, remind yourself that we can read a fraction with the division or the fraction bar as a division sign. So this is like saying 1 whole divided into 9 equal pieces. Or another way to think about it would be 1 out of every group of 9. Now this word every here kind of makes me think, oh, well, I can have more than one group of 9 and find an equivalent fraction that way. So let me take my 1 whole and divide it into 9 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to shade in one of them. So this is my 1 out of every group of 9. 1 out of every group of 9. Now, if I add another group of 9, now instead of 9 equal pieces, I have 18 equal pieces, and how many of them are shaded? 1, 2. So 2 out of 18 is equivalent to 1 out of 9. Okay, next we're going to do our rounding practice. 456 and 34 hundredths rounded to the nearest tenth. Well, we need to locate our tenths place, which is here. And the hundredths place is going to help us determine what we round it to. Remember, 4 or less, let it rest. So this is going to round to 456 and 3/10. We're going to let it rest at 3/10. 456 and 34 hundredths rounded to the ones place, or to the nearest whole number, means that we need to look at our ones place and use the tenths place to help us round. So 3 is, of course, less than 4. 4 or less, let it rest. So I'm going to let it rest at 456. 456 and 35 hundredths rounded to the nearest tens place means I need to look at the digit in the tens place, which is a 5, and use its next door neighbor, the digit in the ones place, to help me round. 5 or more go up a floor. So since 6 is greater than 9, that means we're going to increase our tens place. We're going to round up to 460. All right, so now we're going to add 2 76/100 plus 5 70/100, which of course we know is equivalent to 5 7/10. And remember that I've kind of reminded you to just think of these as being amounts of money, and that will help you remember how to add them. We just line them up by place value. 6 plus 0 is 6, 7 plus 7 is 14, carry the 1. Make sure you bring down your decimal point. If you leave your decimal point out, your number is going to end up being all wrong. All right, 1 plus 2 is 3, plus 5 more is 8. So I've got 8 and 46/100. Okay, we're going to add 2/9 plus 3/4. And in order to do this, we need to come up with a common denominator for 9 and 4. When we're adding fractions, we can't add them unless they have the same denominator. So the way you find a common denominator with fractions is you have to consider both numbers 9 and 4 and come up with a multiple that both numbers have in common. Now remember, multiples are the numbers you say when you skip count by a number. So for 4, I would just skip count 4, 8, 12, 16, 20, 24. And then for 9, you'd say 9, 18, 27, 36. Okay, so 36 I think is going to be our common denominator because 4 times 12, no, that's wrong. 4 times 9 is 36. Okay, so we call this the least common denominator, meaning it's the smallest multiple that both numbers have in common. Least common multiple. All right, so I need to convert 2/9 to some number out of 36. And the way I do that is I multiply both my denominator and my numerator by 4. 9 times 4 is 36. 2 times 4 is 8. So that means 8 out of 36 is equivalent to 2 out of 9. Then I need to convert 3/4 to some number out of 36. And the way I do that is I multiply my denominator and my numerator by 9. 4 times 9 is 36, and 3 times 9 is 27. So 27 out of 36 is equivalent to 8 out of 36. Last, you just add. When you're adding fractions, you add your numerators and leave the denominator alone. So my denominator is going to stay 36, and my numerator, let's see, 27 plus 8, 27 plus 3 is 30, and then 5 more would get me to 35. So 35 out of 36 is what you get when you add those two together. Okay, last we're going to make our line plot using this set of data down here. So we have 2/3, 1/3, 2 halves, which is the same as 1 whole, 4 halves, which we need to talk about, and 1/2. Interesting. Tricky, tricky. Okay, now, 2 things to say. Notice that we have 2 different denominators here. We have thirds and we have halves. So that means that in order to have one consistent interval, we're going to have to find a common denominator. When you're trying to find a common denominator, you need to find the least common multiple. The least common multiple for 3 and 2 can be found by skip counting by 2s, 2, 4, 6, 8, and by 3s, 3, 6, 9, 12, and then find the smallest multiple that's on both lists. So look at this list of multiples and then look at this list of multiples. What's the smallest number that's on both lists? Well, 2 is a very small number, but I don't see a 2 over here. The smallest multiple that's on both of these lists is 6. So 6 is going to be my common denominator. Wow, they made this one hard for you. So we need to convert each one of these fractions to some number of 6. And the way we do that is we multiply the denominator times 2 to get 6, which means we also have to multiply the numerator to get 6. So we've got 4/6 instead of 2/3. For 1/3, we're going to multiply the numerator and the denominator by 2. 3 times 2 is 6. 1 times 2 is 2. So that's 2/6 instead of 1/3. 2/2, we can just kind of leave that one alone because that's the same as 1 whole. 4/2, we're going to leave that for just a second. And then 1/2, I can do that one in my head. That's the same as 3/6. That's easy. So I'm going to do 0, 1/6, 2/6, 3/6, 4/6, 5/6. Oh gosh, I'm going to run out of room. Okay, let me start that one over. So I'm going to split up my number line between 0, 1, and 2. 0, 1, and 2. And then I'm going to skip count 1/6, 2/6, 3/6, 4/6, 5/6, 1 whole or 6/6, 1 and 1, 6, 1 and 2, 6, 1 and 3, 6, 1 and 4, 6, 1 and 5, 6, and then 2 wholes, which is the same as 12/6. All right, so let me go ahead and put my data on here. 4/6, got that. 3/6, got that. 2/6, got that. 1 whole, got it. That leaves me with my 4/2. So let me represent 4/2 really quick with a model because that's probably the easiest way to show you. Here's 4/2. 1/2, 2/2, 3/2, 4/2. So you can see visually that 4/2 is the same as 1 whole and 2 wholes. So I'm going to put 1 X up here.